All right, so good morning, everyone. Let's continue our discussion. So now let's talk about how do you compare decimals, right? This is very, very tricky and often confused by the programmers. Okay, so for example, what if I have, let's say, I've got a is equal to 5.2 f, which means it is a float. Again, I'll say b is equal to 5.2 f. So both of them are float. Now, what will happen if you say if a is equal to b? Okay, if you say if a is equal to b, print same, else print different. All right. So let us try to understand what will happen if you write a code like this, or what will happen if I remove this f and if I just say 5.2. Now, if you just say 5.2, then it is double, right? This is double, whereas this is float, but they hold the same value. Now, what will happen if I just say a is equal to b, right? So this is literally interesting. Let's move to the REPL and we'll see how it behaves. All right, look into this. Comparing double and float. Can you tell me why the first output is false and second output is true? But let's try to see that, okay? So we'll go to our REPL and let's try this out, okay? So I'll say, I is equal to 5.2 f, which means it is a float, right? And I'll say, j is equal to 5.2. Now in this case, if you see the second assignment, j is basically a double. Why? Because 5.2, we already know that by default they are double, they are not float. If you want to make it float, you have to strictly say small f or capital F to say that it is a float, otherwise they will be by default treated as double, right? Now the question that comes to the mind is, what is the output if I say I is equal to j? Look into this. By value they look same, but what if I do I is equal to j? This gave me false. Any reason? Let's see that. Okay, it gave us false. Fine. Now let us try to do something like this. Now I'll say, I is equal to 5.25f. Now see here, I would like to repeat the same example again, okay? I is equal to 5.25f. And I'll say, j is equal to 5.25. Now, one is your float, the other one is your double, right? And now again, let me say I is equal to j. Is it true or false? This time it is true. This is interesting, is not it? Okay. So what we noticed was when I said 5.2f and when I said 5.2, this is float, this is double, okay? But when you try to compare, in this case, this comparison would give me false. It says both are not equal, okay? But if I change this value to 5.25 and if I change this also to 5.25, then it says true, okay? Now let me tell you the reason behind this. It is super interesting. So look into this. It's all about precision, okay? So see, there is a simple formula. I would like to give you that simple formula. If you have 5.25, what you do is remove this 5, okay? Now you have got only 25, okay? Dot 25. What you do? Multiply it by 2. How much you'll get? Dot 50. Again multiply by 2. How much you'll get? 1.00. Which means if I keep multiplying this 25 by 2 continuously, a time would come where it would settle down to something .00. Means it might settle down to a whole number. Okay, there is an end to it. Okay, but if I say dot 2, now multiplied by 2, it is 0.4. Multiplied by 2, 0.8. Multiply by 2, 0.16. Multiply by 2, 32. Multiply by 2, 64. Multiply by 2, 1.28. Again, ignore this 1. Again, multiply by 2. If you keep multiplying by 2 continuously, it would never settle down to a perfect whole number. Okay, which means when you store this 25, whether it is float or decimal, okay, there is an end, which means the precisions are handled perfectly. Whereas if you look into this number 5.2, this is not, settling down to whole number anytime, even if you're continuously, multiplying it by 2, which means there would be little precision difference, which means suppose 0.2 could also be stored like 0.20000000001. Okay, now because there is a possibility that it might be stored something like this, hence they would not be shown equal. Okay, whereas when we talk about 0.25, okay, follow this formula, and because 0.25 is, when you constantly multiply by 2, someday it will settle down to a perfect number. You can say the precisions would remain same, and hence it would always give you the same output. Okay, so let's go back to the screen and we will see with few more examples. So let's try to check that. Okay, 0.2 f is equal to 0.2. What do you think would be the output here? True or false? So 0.2 f is equal to 0.2. One is float, the other one is double, but let's talk about the same formula what we were discussing. If you continuously multiply by 2, it will never settle down to a perfect number, right? Which means it should give me false, and it is false. Okay, let's check with 0.5. 0.5 and 0.5. Now, this 0.5, if you continuously multiply by 2, one time it will settle down to a perfect number. So what do you think would be the output here? It should be true, and this is true. Okay, similarly, let's do one more thing, 125. Okay, so 125 into 2, how much it is? Let's do that. 0.125 into 2 is 0.25 into 2 is 0.5 into 2 is perfect 1. So what do you think would be the output here? True, right? So this gave you true. Okay, so it's not about even and odd, it's about you continuously multiply that number and see if you can get a perfect number here. So are we clear with this comparison? Okay, now let me tell you one thing. This concept holds true for C programming. This comparison holds true for Java. This comparison holds true for Scala as well. And I think it should hold true for Python as well. I have not tested that in Python, but then that should be the concept across, because the floating values and all, they are the standard, right? So it should work in a similar fashion across all the programming language. Okay, so we got I is equal to j to true. Okay, now, but let me tell you one thing. You should not actually use this equal operator to compare the floating values, because that's literally risky, is not it? Think about this. It will sometime give you true, it will sometime give you false, and you'll go mad. You'll say, hey, I see that I have 5.2, and on the other side I also have 5.2, and 5.2 and 5.2 are equal, right? But then because of the precision, it will never return you true, right? So that's really not a great idea to compare a float. So the takeaway from this particular session is, it is not advised that you follow this pattern to compare your float or double, because if you do that, then your code sometime will give you true, your code sometime will give you false based on the value that you have. Okay, so let's see how exactly you should be comparing the floats. Okay, so many times when you are working in a production, you would be required to compare the float values. Okay, if that's the case, then what I would suggest is convert that to a big decimal. Okay, so do something like this. You say, well, num1 is equal to big decimal. This is a class. Okay, and I'll say 5.25. Big decimal is basically a class in Scala. You have similar class in Java as well. Okay, so well, num1 equal to big decimal 5.25. So it gave me a big decimal object in a num1 variable. Okay, similarly, I'll say, well, num2 is equal to big decimal 5.25f, right? So 5.25 and 5.25f, one is double and another one is float. Okay, so if you go by the formula of what we discussed, what should you get if you try to compare these two? 0.25, should you get true or should you get false? You should get true, right? Because 0.25 into 2 is 0.5, 0.5 into 2 is 1.0, right? That means sometime it will settle down to a perfect number. So num1 dot equals num2, yes, it is true. Okay, similarly, you can try this with some other value, 26. 5.26 is stored like this when it is double. It's a double by default. 5.26 float, it is actually stored something like this, right? Now look into this. It is 5.26 and there are still some numbers which are like negligible, of course, but then when we compare directly, it would always give you false, right? And hence that's not the best way to compare these two. So in this case, I'm saying num1 and num2 are they equal? So see, this gave me false just because they both are of different type. What you can do is, so the notes also says the same. If you do this like this, then it will still give you a false. If you want to return it to true, what you can probably do is convert one of them to a float, okay, and then check. So num2, let me check what is num2. Num2 is a float, so this should also work. Just a minute, it gave me still false. Let me convert this also to float. Okay, so what you can probably do is convert your num1 to float, convert your num2 also to float, okay, and then try to do a comparison. Okay, so directly it does not give you, it says one is float, the other one is double, and it might still return you a false. But what you can probably do is convert this to float completely, okay, and then take the comparison, it should return you true. Now let's talk about the next. Try comparing two doubles. Let's try to compare two doubles. Okay, now what we did was we were trying to compare one double and one float, and we got the output like true sometime, false sometime, based on that formula, right? But what if I do something like this? Well, d1 is equal to 5.2. Now this is double, okay, and again I'll say, well, d2 is equal to 5.2. This is also double, right? So since both of them are double, let's say d1 is equal to d2. This returns you true. Why it returns you true is because even if it stores the value like 5.2000001, right, it would take the same precision, and hence it will give you true. Now the question was why it did not work for double and float? Because of the precision. As I said, like float might store it like 5.2000, double might store it like 5.2000001, something like this, right? And if that's the case, then this equal will not return you true. Okay, however, even if you see that this is working perfectly, I would not suggest you to use this approach to compare your double or float. That would be very, very risky. Okay, now doubles are not predictable. How can you say that? See, the problem with the double is like, well, d1 is equal to 5.2. We'll do that with float as well. Okay, let's see what is the output float gives. Well, d1 is equal to 5.2. Okay, done. Now I'll say, well, d2 is equal to 5.1 plus 0.1. What would be your expectation out of this? Our expectation is actually 5.2 only, right? Because 5.1 plus 0.1 should be 5.2, right? Now what it gave me is, it gave me 5.199999, which is not 5.2, right? So hence, if you see, they are literally not predictable. Okay. Now, when you say d1 is equal to d2, see, this is 5.2, and you would be, assuming that this is also 5.2, whereas it is not 5.2. Now, if you say d1 is equal to d2, are they true? They're actually true, but if you see the way they are represented, the way they are stored, they are literally different. 5.19999 is nowhere equal to 5.2, and hence it gave you a false. Let's try doing the same thing with the float as well. Okay, now we'll say, well, d1 is equal to 5.2 f. Now I'll say, well, d2 is equal to 5.1 f plus 0.1 f. Now it gave me perfectly 5.2. Okay, now when I compare these two, it returns me true. Okay, now we can also do something like this. Let's say, write a function to find the absolute difference between two decimals. One could be float, the other could be double, and find out if the difference is negligible. You can actually write your own method if you are not happy with the above approach. Okay, and if you say, no, this does not sound good to me, but let me do what? Let me try to write my own method which can actually return me true or false if the differences are negligible. So what I'll do is, I'll say, well, num1 is equal to 5.2. What is this? This is a double. Okay, now I'll say, well, num2 is equal to 5.2 f. Now this is my float. Okay, now if I try saying, okay, num1 minus num2, I don't know what is the output. I'm actually expecting this to be perfectly zero, right? See, 5.2, 5.2. I'm expecting this to be perfectly zero, but that's not the case. If I try to divide these two numbers, what I got is, I got double. Why I got double? Because one is of double type, the other one is of float type. Since double has the highest storage capacity, right? Hence the final output is double. But if you look into this is a very large negative value. How can you say that? See here, e minus 7. What is the value of e minus 7, guys? E minus 7 means 10 to the power minus 7. So don't you think this is literally 0? This is literally, smaller than 0. Very, very negligible number, right? Now what I got is, I got this number. So probably what I can do is, I can find out a difference like this. Well, difference is equal to math.abs. Math is a class in Scala. It has a method. We'll see a lot of methods present in this class in the coming days. Math.abs absolute. Absolute means don't return me the negative value. Just return me the difference between this. Num1 minus num2. Okay, see here, it still return you the same, right? So let me tell you what is the difference. When I have num1, let's say 5 minus 2, it is 3, right? Whereas 2 minus 5 is minus 3. When you do absolute, what it does, it returns you the positive value always. For example, math.abs, okay, and I'll say 5 minus 3, it return me 2, okay, and I'll say 3 minus 5, it returns me 2, which means it gives me the difference. It does not give me the symbol. What the difference between 5 and 3? How much is the gap between 5 and 3? 2. So absolute actually gives me the gap. It ignores the negative symbol. Okay, so we did this math.absolute because sometime I might get smaller and I might get this larger value. So in order to just ignore the negative symbol, we have used a math.absolute, and this is not a negative symbol, to be very honest. E minus 7 means 10 to the power minus 7, right? Which means 0.0000 something like that. Okay, so hence you are seeing the same result here. So what you can do is, now you can actually do something like this. Hold this value, well, difference equal to math.absolute, right? So hold this in a variable. So we can do something like this. And what I got is, I got a very small number. Okay, now I'll check if the difference is till here. Difference is less than this, right? So if I got some number, okay, but if it is lesser than this, then let me say they are same. So what I'm trying to do is, I'm trying to ignore the negligible differences. Okay, so this is what you can do. Okay, now in this case, what we have done, we have written a small method, a small function. Don't worry, I'll teach you how to write a function in the coming days. Okay, but for now, what we have done is, we've written a function. The way you write a function is like this. The function starts with def. This is the function name. Okay, two types that the function can take. I'm saying, okay, let my first value be float, let my second value be double, and it would return me true or false based on the differences. If there is a large difference, then let me return false. Okay, and we did what? Math.absolute, so that we can tackle the negative value also. And I'm saying, if the difference is lesser than this, then return me true. Okay, so we defined a function is equal. So now in this is equal, you pass number 1, you pass number 2. Okay, so probably mismatch error. So num2 and num1. Okay, and it says true. Let's try to see this. Okay, now I have got is equal method, okay, which takes a float. So 5.2f float. Okay, the second parameter takes a double, 5.2. This is double. Okay, and I'm checking, are they both equal? It will say yes, they are equal. Okay, now if I say 5.2 and 5.3, are they both equal? Then it return me false, because there is a little difference. 5.2 and 5.3, there is a whole difference of 0.1, right? So I wanted to make sure that we don't return true in this case. But what if I say 5.2 5? This is also out of range. Okay, if I say 5.2 00001, so I'm saying, okay, if somebody is comparing 5.2 with 5.2 00001, the differences is very, very negligible. Let's ignore it and say both are same. All right, so now let's talk about auto typecasting. Okay, if you look into this diagram, at any point, if you are flowing in this direction, the direction of the arrow, then you don't have to worry about typecasting. Okay, so basically typecasting means what? Converting the data from one type to another. For example, let's say I have a byte, I want to convert that to integer. Can I do that? Yes, you can do that. Okay, a byte can be converted to integer, of course. An integer can also be converted to a byte. But let's say I want to convert a byte to sort, then you don't have to do that. It can be automatically taken care of. Okay, so if you're following the below order from left to right, then you really don't need to typecast. Scala takes care of it automatically. Now look into this diagram again. You have a byte. You want to convert that to a sort. If you are in this pattern, you don't have to typecast. Let's look into that with an example. Okay. So we'll do like this. We'll say, well, B of byte type is equal to 10. Right? Why did I write here byte? Because if I don't write, then by default it would be treated as int. It's noted, and hence to make this be of byte type, we have to explicitly write byte. Okay, done. Well, b is equal to byte is equal to 10. Okay, next, now I'll say, well, s of sort is equal to b. Now, if you look into this, well, s of sort is equal to b. I'm not typecasting, right? What we have is we have a byte, and this byte is automatically converted to a sort because of this diagram. Okay, so look into this diagram, right? So we're talking about typecasting. So what is the typecasting? Typecasting is basically converting a data type to another data type. It could be integer to sort, byte to sort, integer to long, and so on. Okay. Now, in the real world, there would be a lot of requirement. For example, let's say you have a function m1 which actually takes long. Okay, but in your code you have got a integer type. You have something like well v is equal to 10. This 10 is what? This 10 is integer, right? Because you have not written anything. 10 is a number by default is treated as integer. Now you have integer in hand, but you want to call this method m1 which accepts only long. So can I just say I'll call m1 by passing b? You can do that. Why? Because it will be automatically typecasted. Okay, so if you are following in this direction, if you're going in this direction, if you want the data type to be converted from this to this or this to this or this to this or so on, then you don't have to typecast. It will be automatically taken care of. Okay, for example, let's say you wrote something like this. Well, b of byte type is equal to 10. In this case, you have a b which is a byte type and it is 10. Okay, now suppose you want to convert that to sort, so you can still say, well, s of sort type is equal to b. Okay, you don't have to write a typecasting here. You don't really need to do that, right? If you remember, in Java we used to write something like this. Let's say you have int x is equal to 10. I'm writing a Java code. Okay, and let's say you have long l is equal to 20. Okay, and if you want to say, okay, I want to convert this long to integer, probably you were doing something like this. int c is equal to integer of l. This is what is called as explicit typecasting. Okay, wherein the programmer has to typecast. Why? Because you are trying to convert a long to integer. Long to integer. So if you're going in this direction anytime, then you'll have to explicitly typecast it. Okay, whereas if you're going in this direction, then you can just assign it. You don't really have to typecast. They will be automatically taken care of, which means now I'm here at sort. What if I want to convert this sort to integer? Can I write, well, I of integer type is equal to s? Yes, you can. S is a sort, I is an integer. You try to convert a sort to integer, it falls on in this pattern, and hence you don't have to explicitly do a typecasting. It would be automatically taken care of. Okay, so let's look into the code now. Look into this. What we did is, well, b of byte is equal to 10. Okay, I got a byte. Well, s of sort is equal to b, right? Now, since this byte is here and since your sort is here, they can be automatically typecasted. So you can just say, well, s of sort is equal to b, and you don't have to worry about typecasting. It will be automatically taken care of. Okay, done. Next, now I got a sort. I want to convert that to probably integer. Okay, so you can say, well, I of integer type is equal to s. Okay, so this sort got converted to integer. Now I has got a value 10. Okay, now similarly, this integer you want to convert to a long. So you can say, well, L of long is equal to I. well L of capital long, okay, because in Scala long is a class, so well L of long is equal to I, and then this 10 is assigned to L variable where this L is basically a long. Okay, similarly well F of float is equal to L. This gives you a warning possible loss of precision. You can just ignore it, that's absolutely fine. Similarly, well D of double is equal to F. I got double is equal to 10.0. Okay, now likewise you have got a character here. We have moved from here to completely here. We had a byte, converted that to short, converted that to integer, converted that to long, convert that to float, convert that to double. Okay, now likewise you have a character. Character cannot be converted to short, but character can be converted to integer without any problem. Okay, which means, can I write something like this? Well, v, which is a char type, is equal to a, and remember the Unicode gets stored, which is 65. Okay, and can I say, well, I, which would be integer, is equal to v. See here, this v is basically a character. Okay, and I'm saying I want to convert this character to integer. Can I do this? Yes, you can. Okay, but can I say, well, I of sort is equal to v? You cannot. Why? Because they don't fall in this pattern, right? A character can be converted to integer, a character cannot be converted to sort directly. It says a mismatch error. Okay, so when you are following this diagram and if you're going in this direction, you don't have to worry about typecasting, it would be taken care of automatically. Okay, now you can have one good question here. Okay, so the question could be, hey, long looks like a 8 byte and float looks like a 4 byte. When you say long can be converted to a float, don't you think we will miss some numbers? Looks like it is something like this. Hey, I have a container of 8 liter of milk and you are asking me to store that into a 4 liter container of float. Okay, probably that could be a question in your mind. So I had the similar question way back, okay, long back. But let me tell you how it works. Okay, it works because the way your integer stores the data, the way float stores the data is different. The pattern is different, right? For example, if you look into the long range is what? Long is 8 byte. 8 byte means 8 into 8, 64, which means 2 to the power 63, right? That's the maximum value it can store, is not it? So 2 to the power 63 is the maximum value it can store. 2 to the power 63 is this. It shows me something like this, right? But then let's say size of long in Scala or Java, okay, remains same. So if you look into this, it can store till 2 to the power 63, okay, but your float can store more values. What is that? Float can store 3.4 e to the power 38. Now when you say e to the power 38, that means 10 to the power 38. Think about this. 10 to the power 38 is way larger than just 2 to the power 63. Make sense? Okay, so the way it stores the data is different, and that's the reason it is perfectly valid. Okay, you may get a question like this: long takes 8 bytes, float takes 4 bytes. How is it even possible to store a long to a float? Let's do one more experiment here. Okay, what I'll do is I'll say long dot max val. We have this, right? So see, it can store only this value, only this much. That's the largest value a long can hold, right? But what is the value your float can hold? Float dot max value. It can hold e to the power 38. That means 10 to the power 38. So 38 times 0. So see here, how many digit it is here? Only 19 digits here, right? But if you're working with float, then you can have 10 to the power 38. That means 38 zeros, right? Which is way larger than your long. Okay, so you can easily say something like this: well, f of float is equal to long dot max value. It can easily store it, no problem at all, right? See here, it took only e to the power 18 space, and it has still more space left. 18, 20, 38, 20 more space is left, 20 more such zeros, right? So what I'm trying to tell you is the float can store larger value than the long. Clear? Okay, now let's look into this. So we have also done like this: well, c of character is equal to a, and I'm saying well, I of integer is equal to c. So it's like 65. Okay. Now, if you need typecasting in the reverse order, example, an integer to byte, try to check in API if you have any 2-byte method to convert. Prefer 2xxx over as instance of. We have already talked about this in our previous lessons, right? So you may say, hey, this looks good. The diagram looks good. But what if I want to go in a reverse direction? For example, I have a float. I want to convert that to integer. Float to integer, right? Now you want to go in the reverse direction. If that's the case, what you should do? Let's see that, okay? So let's say I have, well, f is equal to 2.5 float. I got a float value, done. I want to convert that to integer. So if you want to convert that to integer, in Java, we used to write like this. It will not work in Scala, right? Okay. So what you do, f is basically a object of float class. Okay. Now just check if you have 2xxx method. Okay. 2I. Okay. There is a method called toInteger. Okay. So otherwise what you do, f dot, just write 2 and just give a tag. It tells you what are the method you can call. So see here, float can be converted to byte, it can be converted to character, it can be converted to sort, it can be converted to integer, it can be converted to long, which means you have all the methods already available, which allows you to convert this float to any other lower range data type. Okay, even you can convert that to double, right? Which means if you go to every class and check, you have two xxx method to get that value converted to any other data type. Just use that. Okay, so in my case, I wanted to convert that to integer, so I'll say, well, res result is equal to f dot to int. Now obviously when you try to convert that to integer, your decimal value 0.5 would be removed, right? Because it cannot even store. Now it is not 3. It's wrong to say 2.5 is equal to 3. No, right? So it'll just store this part, just 2 part. Okay, all right. Now let's move on. So take this example. Okay, now let's say we have, well, I is equal to 10, which is integer, and I'm saying, well, b of byte is equal to I. This is wrong. Why? Because your I is integer and you are trying to convert that to byte, which is not allowed by default, right? It does not fall under auto conversion. You need to explicitly typecast it. Okay. So the best way would be, just go to this I and see if you have 2-byte method or not. Of course you have. Okay. So use 2-byte method to convert that to byte. Okay. Otherwise, can I do something like this? I have got I, and I is basically an integer. I know this I is an integer. Can I use as instance of? Of course, as instance of, let me say byte. Now when I use as instance of, it actually says, hey, is it possible to convert this to a byte? If it is possible, please convert that. Okay, and as you know, as instance of may throw you an error exception if it is not compatible. What kind of exception it will throw you? Class cast exception. Okay, so it is always recommended that you use 2xxx method over as instance of. Okay, now we have a last topic, unit. So we have learned all the data types. Okay, but then we have got one more extra data type in Scala. We call it unit. And what is unit? Let's understand that this represents lack of data. It is similar to void in Java. If you write a function that does not return any value, you would specify the return type as unit. The unit literal is empty pair of parentheses, which is a representation of not having any value. If you want, you can define a value of unit type, but it's basically used in functions and expressions. Okay, so let me say, well, result is equal to braces. When I do this in Scala 2.x, you get the output like this. Okay, in Scala 3, you don't get to see anything. Okay, so this is basically the representation of unit. Okay, when you write a function, you basically write a function like this. Function. Okay, what is the function name? M1. Do you want to pass any parameter? Probably, let's say I want to pass a parameter of int type. Okay, and you will write this equal to separate the body. And what is the return type you want to say? Probably unit. Now if you look into this, This is how you write a function, okay? But we'll talk about this function in great detail in the coming class, right? So if you look into this small code, what I've done is I've just written a function called m1, and I'm just saying it will return void. It will return nothing, okay? Like if you have written a code in Java, you might have seen that every method that you write must return a value. The method does not return a value, you should actually use void to say that this method will not return me value, okay? Same thing is what you do in Scala using unit. So unit is basically a replacement of your void, okay? In Java you have void, in Scala you have unit. That means it does not return any value, okay? So how do you denote unit? Unit is denoted by this.